Hello everybody, it's Miss Maneely, and I am going to give you a quick tutorial on other ways of evaluating trig functions when you can't use a unit circle. So for example, if you don't know the angle measure, you have to rely on some of the lessons that you learn in geometry, like SOHCAHTOA and right triangles, to be able to evaluate those functions. Before we do that though, let's do a quick review, since we're going to have a quiz next class, on what we've covered so far. So the first thing we talked about in this unit, actually let me go back a little bit. All right, do a quick review. So if I want to convert degrees to radians, so remember if I've got an angle like, I don't know, 75 degrees, and I want, whoops, that's not a degree symbol. If I want to convert that into radians, I need a pi, and so I want to multiply by the fraction that has the pi on top. So I'm going to multiply by pi over 180. You do also want to remember that your angles must be in standard form, so they have to be between 0 and 360 or 0 and 2 pi, and I'll talk in number 3 about how to fix that if that's the case. In number 2, converting radians to degrees. So like if I have pi over 8, for example, how do I fix it so that it's in degrees? Well, if I want it to be in degrees, I need to get rid of pi. So I'm going to multiply by the fraction that has the pi in the denominator. Because pi over 180 and 180 over pi is just 1, because 180 degrees is equivalent to 1 pi. So all we're doing is changing the way the number looks. We're not actually changing its value when we multiply by either of those two fractions. Okay. We also need to make sure our angles are in standard form. And it's usually easier to do this when they're written in degrees than it is when they're written in radians. So to get angles in standard form, we're either going to add 360 or subtract 360 to get the angles back between 0 and 360 degrees. So if I have a negative measure, I'm going to add 360. So if I have like a negative 15 degrees, I'm going to add 360 to that, and that'll give me the positive angle, or give me the same angle in standard form. If my angle is over 360 degrees, then I need to subtract 360 to get it back on that unit circle. The formula for arc length, remember arc length, we use a letter S. I'm still not sure why, but it's S is equal to theta times R, which is your radius. Theta, remember, is just your angle, and it must be measured in radians. And so if you're given an angle and it's measured in degrees, you're going to have to make sure that you change it back to radians by multiplying by pi over 180 first. And remember, R stands for the radius, and so if you're given the diameter, you have to remember to cut it in half to get the radius. In number 5, it says, recall that the point xy is the same as, well, if you think about a unit circle, let me just kind of go down here for a second. So if this is the point xy, if I draw a segment to that point, this angle is called theta, then the point xy is equivalent to the cosine of theta, comma, sine of theta. Because the cosine of theta is just going to correspond to the x-coordinate, and the sine of theta is going to correspond to the y-coordinate. And the reference angle, theta, is always the angle that is in the first quadrant. There's actually 4 points on the unit circle that correspond to that same reference angle. It's going to be this point over here, which is going to have a negative x value and a positive y. There's going to be a point down here, which is going to be negative x and negative y. And then there's going to be a point in the fourth quadrant, which is going to have a positive x and a negative y. The actual values of x and y are going to be the same. You would just want to change the signs to get all 4 of the points around the unit circle. Remember that cosine of theta is just going to correspond to your x value. The sine of theta is going to correspond to y, and the tangent is going to correspond to y over x. The secant is going to be 1 over x, or simply flip the x coordinate. The cosecant is going to be 1 over y, or simply flip the y coordinate. And the cotangent is going to be 1 over the tangent, or simply x over y. So when you're simplifying these expressions, remember if you're dividing two fractions, that's the same as multiplying by the reciprocal. And then you also want to make sure that all of your fractions are written properly, so you can't have any square roots in the denominator. And I'll just do a couple examples to help you remember. So the warm-up that you were asked to do in class today begins with converting the angle negative 225 degrees into radians. Well, before I do that, I notice that I have the negative angle. So what I need to do is add 360 to get that on my unit circle. So I'm going to take negative 225, and I'm going to add 360. And that gives me 135 degrees. Well, if I want to change it to radians, that means I need a pi. So I'm going to be multiplying by the fraction that has the pi on the top. Well, 135 degrees, that's just going to be over 1 since it's a whole number. And then to fix this, or to rewrite it, since this is just multiplication and division, so I'm only going to deal with the numbers. I'm going to take 135, I'm going to divide it by 180. I don't want to have a decimal, though, so I'm going to go to my math option and choose fraction, and so when my calculator will go ahead and rewrite this in lowest terms. It's going to be 3/4, but I don't want to forget the pi, so it's actually 3 pi over 4. If I want to convert 17 pi over 4 to degrees, I want to get rid of the pi. So this is the time that I'm going to multiply by 180 over pi. That way my pi's cancel. And then all I need to do is perform the multiplication and division. I'm going to take 17 times 180, and then because the 4 is in the denominator, I'm going to divide by 4. And when I do, I get 765. Well, 765 is too big, so I need to subtract 360. And I get 405. Well, that's still too big, so I'm going to subtract 360 again. And that gives me 45 degrees. So in number 3 now we're dealing with an arc length issue. So we know that the arc length of a sector is 5 pi over 4 feet, and we know that theta is equal to 30 degrees. So remember, our formula is S is equal to theta times R, but theta has to be measured in radians, and right now it's given to me in degrees. So I need to multiply by pi over 180 to get that into radians, which means I'm going to take 30 and divide it by 180, and then make sure that I write it as a fraction in lowest terms. That's going to be 1/6, or simply pi over 6. Okay, so if I want to find the radius, that's what's unknown. So I know that I'm going to have to make up a little space here. So I know that my arc length is 5 pi over 4, so that's going to go on this side of my equation. I know theta is pi over 6, and I don't know r. So to solve for r, I can either divide both sides by pi over 6, but if you remember, dividing by fractions is the same as multiplying by the reciprocal. So I'm actually going to multiply both sides by 6 over pi. And so that way my 6's cancel on this side, my pi's cancel on this side. On the left-hand side, my pi's are going to cancel, and I can just deal with my numbers. It's going to be 6 times 5 divided by 4. And that gives me 7.5. So I know the radius is going to be 7.5, and then please don't forget your units. In this case, it's going to be feet. It also is asking me to calculate the diameter. Well, the diameter is just going to be twice the radius. And so the diameter must be 15 feet. In number 4, it says to determine all points, x, y, on the unit circle that correspond to a reference angle of 25 degrees. So notice that 25 degrees is not on our unit circle. It says to use our calculator here. Well, if I want to find the coordinates x, y, remember x corresponds to the cosine of theta, and y corresponds to the sine of theta. So you do have to remember to do this step. If I want to find all of the points that correspond to 25 degrees, I'm going to have to make sure that my calculator is in degree mode. And luckily it is. And so now to find the x-coordinate of the first point, I'm just going to take the cosine of 25 degrees. And that gives me an x value of 0.906. And then the y value is just going to correspond to the sine of 25 degrees. Okay, and that's going to be 0.423. So this is the ordered pair that I would find. So if I have my unit circle, right? So 25 degrees is probably about right here. So I just found this ordered pair. But remember, when we're dealing with what we call a reference angle, we could also be dealing with this point, and this point on the unit circle. I really don't have to do any other calculations. All I need to do is change the signs of x and y. So this is the point in my first quadrant. In the second quadrant, the x value is going to be negative, and y will be positive. In the third quadrant, they're both going to be negative. And in the fourth quadrant, x is going to be positive, and y will be negative. So that's all you have to do. Okay, and number 5, it says to evaluate each function. So I'm actually just going to keep the unit circle that I have here. So the sine of 3 pi over, or negative 3 pi over 2. So remember, this is pi over 2, this is pi, and then this would be a positive 3 pi over 2. But because it's negative, instead of going forward around the unit circle, I have to go the other way. So that means that a negative 3 pi over 2 is equivalent to a positive pi over 2. So this is the same as the sine of pi over 2. And the sine of pi over 2, well, this is just the ordered pair 0, 1, and the sine corresponds to the y value. The cosine of 4 pi over 3, well, 4 pi over 3 is right there, because I know all my pi over 3s are going to be closer to my y-axis. That means the x value is going to be smaller, so I'm dealing with a negative 1/2 and a positive square root of 3 over 2. This is asking for the cosine, so it's negative 1/2. The tangent of 180 degrees, that's this point here. The coordinates of that are going to be negative 1, 0. I know tangent is equal to y over x, and 0 divided by anything is just 0. The secant of negative 60 degrees. Well, here's a positive 60 degrees, so a negative 60 degrees is down here. And that's going to correspond to a negative 1/2, and an, oh, not a negative 1/2, it's a positive 1/2, and a negative square root of 3 over 2. And this is why it really helps to understand your unit circle, because I don't have to draw the whole thing if I know where the angle is and I know what quadrant it's in. And I remember the pattern in terms of my coordinates. So if I want to find the secant, remember the secant is just the reciprocal of the cosine. Secant and cosine go together. So I'm just going to flip the 1/2, and that just becomes 2 over 1 or just 2. Let's see, the cosecant of 6 pi. Well, remember, this is 0 pi. Over here is 1 pi, and then we're back to 2 pi, 3 pi, 4 pi. So all my odd functions of pi are going to be over here. And all my even multiples of pi are going to be over at 0 degrees, or 360. And so I know the ordered pair here is just 1, 0. The cosecant, remember, is going to correspond to the y. It means flip y, or 1 over 0. Well, I can't have a 0 in the denominator, so we say it's undefined. And then the cotangent of 450 degrees. Well, 450 degrees, I have to adjust it. So I'm going to actually subtract 360. And that means it's a 90-degree angle. So cotangent of 90 degrees. Well, here's my 90-degree angle. Cotangent, remember, is x over y. So that's going to be 0 over 1, which is just 0. Okay, so that was just a quick review. All of this is going to be on the quiz on Thursday and Friday, depending on if I have you on A day or B day. I have one really short lesson to show you before we move on to the review. And so let's first talk about, suppose that we're dealing with the point negative 1/2 and the square root of 3 over 2. If I think about where that point is on the unit circle, let me see if I can, I think I have a copy. So we said negative 1/2 and positive square root of 3 over 2. So that is this point right here. And I know that that corresponds to an angle of 120 degrees or 2 pi over 3, whichever way you want to look at it. So theta, we said, is either 120 degrees or, what did I say, 2 pi over 3? Okay, so if I wanted to find the cosine, well, the cosine, remember, is just going to be the x-coordinate of this point. Or I can think of it as, you know, if I'm dealing with a triangle, SOHCAHTOA, I'm dealing with the adjacent over the hypotenuse, which is just 1. So it's pretty straightforward in this case that I know the cosine is going to be negative 1/2. The sine is going to be the square root of 3 over 2, because it's just going to correspond to my y value. The tangent is going to be y over x. And remember, if I'm dividing fractions, I have to multiply by the reciprocal. Those 2's are going to cancel, so we'll have the negative square root of 3. The secant is just what happens when I flip x, so that's just going to be negative 2. The cosecant is when I flip y, so that'll be 2 over the square root of 3, which I'm not allowed to have, so I've got to multiply everything times the square root of 3 over the square root of 3. That's going to be 2 times the square root of 3, and then remember, the square root of 3 times the square root of 3 is just the square root of 9, and the square root of 9 is 3. And I can't simplify that any further. The cotangent is just going to be the flip of the tangent, which means I'm going to have 1 over negative square root of 3. Again, I'm not allowed to have that square root of 3 down there, so I multiply everything times the square root of 3 over the square root of 3. Notice I don't have to multiply by the negative at all. I just ignore that. When I multiply through, I'm going to have the square root of 3. My fraction is going to be negative. It doesn't really matter where you keep it. The square root of 3 times the square root of 3, remember, is the square root of 9, which is just 3. Okay, so that's pretty straightforward. That corresponds to what we've been doing. So if you don't know theta, it doesn't really matter. I can still find the cosine. This is just asking what is the cosine of 120 degrees. And I don't really need to know that the angle is 120 degrees when I know that the point is on the unit circle. But what happens when the point is not on the unit circle? So if we take a look at this example, we're dealing with the point 3, 4. And it's a point we're going to say is on the terminal side of an angle in standard position. Remember, in standard position, that just means that our initial side is on the x-axis. And since it's the terminal side crosses over the point 3, 4, that's right here, I don't know this angle because 3, 4 is not on my unit circle. Remember, my unit circle would be here. This is my unit circle because, oops, I made it a little too big. This graph isn't perfectly square, so it looks a little funny. My unit circle is here. My unit circle, we're dealing with a radius of 1. So in this case, I know my radius isn't 1. It's going to be bigger than that. So let me erase this so that I can see what I'm doing. Okay, so if I want to find the cosine of theta, well, I don't know what theta is. And I can't just say in this case that the cosine is equal to 3 and the sine is equal to 4 like we were able to before. What worked for us before worked because our hypotenuse was 1. And that's not the case this time. Since we're not on a unit circle, it's not as straightforward as it was before. So what I'm going to do is follow these steps. It says to drop an altitude to the x-axis to create a triangle. So I'm going to start at my point 3, 4. And I'm going to drop an altitude and turn this into a triangle. So here's the triangle now that I'm dealing with. And it's a right triangle. I know since this is the ordered pair 3, 4, that that this side, my adjacent side, has a length of 3, and my opposite side has a height of 4. Now this triangle is not drawn to scale. Obviously you can tell that it looks like the side that has 3 units looks a little bit longer than the side with 4 units. So in order to deal with SOHCAHTOA, I have to find the length of the hypotenuse. And so that's the third step here. So I already labeled the sides, and now we're going to use the Pythagorean theorem to find the length of the hypotenuse. So remember that 3 squared plus 4 squared is going to equal whatever my hypotenuse is. Excuse me. And so that's going to be 9 plus 16. Well, that's 25. And if I take the square root of that, I know that my other side is going to be 5. This is also a popular pattern with right triangles, the 3, 4, 5 triangle. So now I can go back to using SOHCAHTOA and evaluating each of these trig functions. Even though I don't know what theta is, I don't need to know it because I know that the relationship, I can use the relationship between the sides to evaluate the cosine. So I know that the cosine is going to be adjacent over the hypotenuse. And so the adjacent side in this case is 3, and the hypotenuse is 5. And I don't really need to do anything else. I know with my sine, that's going to be opposite over hypotenuse. And so the side opposite is 4, and the hypotenuse is 5. The tangent is going to be opposite over adjacent. And so that just is going to be 4 over 3. The secant, remember, is just flipping the cosine. So if I flip the cosine, this becomes 5/3. The cosecant is just the flip of the sine, which is going to be 5/4. And the cotangent, I'm just going to flip the tangent, which is 3/4. So that's pretty straightforward. You don't actually need to know theta. It doesn't have to be on a unit circle. We can go back to what we did in geometry and just use SOHCAHTOA to evaluate the functions without knowing the value of theta. Couple things to keep in mind, and you probably saw this on your unit circle where each quadrant there lists positive and negative and then it's blank. Something to keep in mind, when I'm evaluating my trig functions in the first quadrant, everything is positive. The sine is positive, the cosine is positive. That means the tangent, the cotangent, the secant, the cosecant, all of my functions are positive in the first quadrant. So they're all positive in the first quadrant. In the second quadrant, though, all of my x values are negative. And so if my x values are negative, that means that the cosine is going to be negative, the secant is going to be negative, the tangent and the cotangent will also be negative since they both involve x. So the only thing that is going to be positive in the second quadrant is going to be the sine and the cosecant, because the cosecant goes along with the sine. So And since the sine is the one that's most important, these are the ones that are positive. In the third quadrant, both x and y are negative. That means the cosine and the sine are both negative. But when I take the ratio of those values for tangent and cotangent, they're both going to be positive. So in the third quadrant, it's just the tangent and the cotangent that are positive. Everything else is going to be negative. And then in the fourth quadrant, x is positive, but y is negative. So the cosine's positive, but the sine is negative. So the only things that are going to be positive in the fourth quadrant, whoops, are the cosine and the secant. And so this is just another quick way that you can check to make sure you've evaluated everything correctly. So if you just remember A, S, T, C. So all students take calculus is one way that you can remember which functions are going to be positive in each of the quadrants. This may not really make a lot of sense right this second, but when we start evaluating functions for other angles that are not on the unit circle, you'll see how it makes a little bit more sense. But just remember, everything's positive in the first quadrant. In the second quadrant, it's only the sine and the cosecant that are positive. In the third quadrant, it's just the tangent and the cotangent. And in the fourth quadrant, it's going to be the cosecant and the secant. So all students take calculus would be one way to remember it. There are other ways to remember it that I'm not going to record, but they're easier to remember. All right, so let's take a look at another example. In number 3, it says, suppose that we're dealing with a point 8, negative 6, and it falls on the terminal side of an angle theta. So if I think about my coordinate plane, I'm not going to bother putting the circle in here anymore because I know that the point 8, negative 6 is not on my unit circle. It's well far beyond 1 unit from my radius. So if I think about where this point is, 8, negative 6, actually, let me draw this a little bit different. Go like this. So the point 8, negative 6 is going to have a positive value for x and a negative value for y. So that's where the point 8, negative 6 is. So if I draw my angle, or if I draw my ray going out to that point, we have, this is 8, negative 6. And this time when I draw my altitude, I always draw the altitude to the x-axis. That's what my triangle looks like. This is theta. Okay, I know theta is going to be a negative angle. I honestly don't really care what it is because I'm just trying to evaluate the cosine, the sine, and the tangent. And since it's not on the unit circle, it's not as straightforward as saying that the cosine of theta is 8 and the sine is negative 6, unfortunately. So what I'm going to do is I'm going to label the sides of this triangle according to the point. So I know that the 8 corresponds to the x value, and the negative 6 corresponds to the y value. Now when I go to calculate my hypotenuse, I'm not going to really have anything to do with the negative. You can include it if you want. I know basically that I'm taking 8 squared plus, now the length of the side is not negative 6. It's actually a positive 6. But even if you include the negative in there, when you square it, it's going to become positive. So make sure that both numbers end up being positive. So this is going to be 64 plus 36, and that gives you 100. And so that means that C must have a length of 10. Now your hypotenuse is always going to be positive. Remember that. Your hypotenuse is always positive. So if I take a look, now I've got my triangle. Since theta is here, this is my opposite side, and this is my adjacent side. And so with cosine, it's just going to be adjacent over hypotenuse, or 8 over 10. And you do want to reduce these fractions to lowest terms just because that is the proper thing to do. And 8 over 10 is 4/5. If you forget how to do that, you can just do 8 divided by 10 and then use the math option on your calculator to give you 4/5. The sine is going to be opposite over hypotenuse, or negative 6 over 10, and that's going to reduce to negative 3/5. The tangent is going to be opposite, negative 6 over adjacent, which is 8, and that's going to reduce to negative 3/4. The secant, remember, we're just going to flip the cosine, 5/4. The cosecant, we're going to flip the sine, 5 over negative 3, or you can put the negative out in front, it doesn't matter. And then the cotangent, I'm just going to flip the tangent, which is negative 4/3. Okay, pretty straightforward. It does get a little bit more complicated. excuse me, it does get a little bit more complicated when your hypotenuse is not a whole number. So you will have to sometimes rationalize the denominator like we did in the other examples. But if you remember when I was talking about the all students take calculus, let me just do this real fast. We said if we're dealing with the first quadrant, all of my functions are positive. If I'm in the second quadrant, remember our quadrants look like this. They go counterclockwise. This is just the sine and the cosecant function. And then in the third quadrant, it's the tangent and the cotangent function. And then in the fourth quadrant, it's going to be the cosine and the secant function. And so if I think about what quadrant this angle is in, it's in the fourth quadrant. So if I go back and just double check to make sure that my cosine and secant are the only answers that are positive, and in that case that is positive and that is positive, everything else is negative. So it's just another way that you can double check to make sure that you didn't lose a negative along the way. And that is something that students sometimes forget to do, is include the negative when they're building their triangle, since they're used to having the lengths of the sides of a triangle always be positive. I think that is the last. No, here we have two more examples. What I'd like you to do is pause the video and then check your answers in a minute. So if you could press pause and then come back after you finish the examples, that would be great. Okay, let's go over your answers. So in number 4, the first thing you want to do is draw yourself a picture. Make sure that you plot the point in the correct quadrant. And so the point 15, negative 20, is going to plot you again in the fourth quadrant. And so that means that the x value or the adjacent side is going to have a length of 15, and the opposite side is going to have a length of negative 20. Again, ignore the negatives when you're trying to do your Pythagorean theorem, because when we're dealing with the length of a side, they should be positive. I put them in there because it is a common mistake that students do, and I just want to reinforce making sure that you put it in parentheses before you square it so that all of your answers come out positive. When you do that, you should get a hypotenuse of the length of 25. And so remember, this is your opposite side, this is your adjacent side, and this is your hypotenuse. Your hypotenuse is always, always, always positive. The sine is going to be the opposite over the hypotenuse. Sorry. Cosine is adjacent over hypotenuse, so that's 15 over 25. Just make sure you reduce it. The tangent is going to be opposite over adjacent, so negative 20 over 15. It gives us negative 4 over 3. The cotangent, I'm just going to flip that upside down, and it becomes negative 3/4. In the next problem, this time our point is going to be in the third quadrant. And so both the x and the y value are negative. So my x value is negative 12. That gives me the adjacent side. The opposite side is negative 5. When I plug them into my Pythagorean theorem, and honestly, this is actually not proper at all to put those negatives in there, but I know most of you do it. So I'm only putting them there to reinforce making sure you put parentheses around those negative numbers before you square them. And that way everything comes out positive. The length of your hypotenuse is 13. So if I want to find the sine, I'm just going to do opposite over hypotenuse. That's negative 5 over 13. The cosine is going to be negative 12 over 13 because that's just your adjacent over the hypotenuse. The cosecant. So notice now that I'm mixing them up. You have to remember the relationship. The cosecant, remember, goes along with the sine. It's just the reciprocal. So that's going to be negative 13 over 5. The cotangent is just going to be x over y, or in this case, it's going to be the adjacent over the opposite side, and those negatives will cancel. So again, remember, this is my all. This is just the sine and the cosecant function that are positive. This is the tangent and the cotangent function that are positive. And this is the cosine and the secant function that are positive. All students take calculus. And so I can do a double check. Since I'm dealing with the third quadrant, the only answers that should be positive are the ones associated with tangent and cotangent. And if I look, my cotangent is positive, everything else is negative. Okay, so that's just a quick way to make sure that all of your signs are correct. And by sign, I mean S-I-G-N, positive or negative. And I believe that is the last problem. Okay, so for homework tonight, you have to do a review of everything that we've just discussed, including going all the way back to radians and degrees, remembering your arc length formula, being able to remember your unit circle, so you'll have another opportunity to retake that quiz. and I'll just replace the old quiz grade with whichever number is higher. So you're actually going to get 2 grades on Thursday and Friday, one for the unit circle and then one for all of your trig functions. If you have any questions, please make note of which problems you want help with, and then come prepared with those questions in class or come stop by during Bulldog block.